All right, Chapter 2, Reasoning Improves. Let's start off with conditional statements. A conditional statement is a logical statement that has two parts. It has a hypothesis that we're going to call P and a conclusion that we're going to call Q. And when we write it in the if-then form, which is going to turn out to be our favorite form, the if part contains the hypothesis and the then part contains the conclusion. So what does that look like? So if hypothesis P, then conclusion Q. If P, then Q, and symbolically, we will write it like this, where P implies Q. So let's look down, let's identify our hypothesis. Well, if P, hypothesis, so this is going to be our P, and everything after the then is going to be our Q. So hypothesis and conclusion. That's why if-then forms are favorite. It simplifies some of this stuff. So let's identify our hypothesis and our conclusion, and then we rewrite it in the if-then form. So all birds have feathers. So birds are going to be our hypothesis, and having feathers is going to be the conclusion. We're going to write this in the if-then form. So if an animal is a bird, then it has feathers. So if it's an eagle, if it's a pigeon, it's going to have feathers. If it's a dog, no feathers. All right, next one, same process. So what's our hypothesis going to be? If you are in Texas, if you are in Houston. Well, the if kind of gives it away. Here, the second half of the sentence is going to be the hypothesis, and the first half is the conclusion, because being in Texas depends on whether or not we're in Houston. So if you are in Houston, then you are in Texas. So just another example of it. And the reason we like the if-then form, it lays it out nice and simple for us, so we can do things to it. For example, we could negate it. Well, negation sounds like negative, and in fact, when we negate a statement, we're going to take the opposite of the original statement. So to write the negation of statement P, we're going to write this little squiggle before the letter. And it's the same little guy we use like when we say something is congruent. So we're going to say that it's not P. In symbology, we're going to say squiggle P, not P. And we're just going to take the opposite of it. So if the ball is red, the opposite of the ball is red is the ball is not red. The opposite of the cat is not black, is the cat is black. So kind of think of it like we're doing math and we're multiplying through by -1. If it's already negative, it makes it a positive. If it's a positive, it makes it a negative. We're going to just take the opposite. All right. Now we're going to breeze through some more examples. We're going to write some if-thens and then negate. So if we have a 30-degree angle, then we know it's an acute angle. So if an angle is 30 degrees, then it is acute. (2x plus 7 equals 1 because x equals -3. Well, because it's kind of giving away the farm here again. So we know that x minus 3 is our hypothesis, and 2x plus 7 equals 1 is going to be our conclusion. So if x equals -3, then 2x plus 7 equals 1. Down here we're going to do negations again. So the opposite of the shirt is green is the shirt is not green. And the opposite of the shoes are not red are the shoes are red. So that's why we like the if-then form, because it gives us the ability to do different things with our logical statements. But there's more. We have related conditionals. And these are conditionals that are related to our original conditional statement. So if we start with a conditional statement of if P then Q, with related conditionals, we can take the P and Q and do some interesting things with it to expand our knowledge of the logic world. So to write a converse, when we're talking about a converse of a conditional statement, we're going to exchange the hypothesis and the conclusion. We are just going to flip them around. So instead of if P then Q, we're going to have if Q then P. And our original P to Q is going to switch over to Q implies P. That's the converse. The inverse, on the other hand, we're going to take our original conditional statement and we're going to negate both the hypothesis and the conclusion. So we're going to have if not P, then not Q. So converse, the P and Q flip sides. Inverse, the P and Q stay where they're at, but we negate both of them. Which brings us to the contrapositive, which is the converse and the inverse put together. First thing we're going to do is we're going to write the converse. So instead of P to Q, we're going to write Q to P, and then we're going to negate both sides. So if not Q, then not P. And symbolically, we'll write that like so. And these related conditionals, generally what you're going to have, two statements are both going to be true or both going to be false. And those are called equivalent statements. And we'll see how those go here in just a second. In fact, let's do that now. So, Q is you are a musician. RP is you are a guitar player. So let's write our our statements down and determine if they're true or false, and then we'll look at the equivalency of them. So P to Q. P is you are a guitar player. So if you are, a guitar player, then you are a musician. Well, guitar players are musicians. That one is clearly true. Now let's go to the converse. We're going to flip around the P and the Q. So if you are a musician, then you are a guitar player. Well, to be a musician, you just have to play an instrument. You don't have to play the guitar. Lots of high school bands have trumpet players have no idea how to play guitar. So we know that's false. Let's do the inverse. So we're going to do not P and not Q. So if you are not a guitar player, then you are not a musician. Well, what if you're a trumpet player? Still not a guitar player, but are a musician. So that's going to be false. Then the contrapositive, we're going to take our original P to Q and we're going to flip it and negate it so we get not Q to not P. So if you are not a musician, then you are not a guitar player. So let's think about this one. Guitar players are musicians. So if I'm not a musician, I'm not a guitar player. I'm also not a trumpet player or clarinet player, but this is going to be true. Now remember a few minutes ago when I said we'll talk more about equivalent statements? Here we got two truths. And what we're going to find is conditional statement and contrapositive are going to be the same. They're going to be both be true or both be false. And then our converse and our inverse are going to both be true or both be false. In fact, let's go back up here and let's make a note. Our conditional statement is equivalent with the contrapositive the converse is equivalent with the inverse is equivalent with the converse, and the contrapositive is equivalent with the original conditional statement. And by equivalent, we just mean true or false. They go together, true or false. All right, so let's go through another set of examples, and then we will go from there. All right, so our P, the stars are visible, and our Q, it is night. So let's put it into our if-then form. So if the stars are visible, then it is night. Okay, so if I can see the stars, the sun's not out, the sun's not in the sky, it has to be night. It has to be night. So that's going to be true. Let's look at the converse. Because we're reversing our P and our Q. So if it is night, then the stars are visible. Well, we know that it could be nighttime and overcast, or nighttime in LA or Chicago, and you can't see stars. So that's going to be false. The inverse. We're going to take our original conditional statement and negate both sides. So if the stars are not visible, then it is not night. Well, the same example works as our converse. It could be overcast. It could be in a big city. Now let's take our contrapositive and reverse our P and Q and then negate them both. So if it is not night, then the stars are not visible. Well, we know we can't see them in the day, so that is going to be true. And that's a good place to stop this video. We will pick it up the rest of section 2.1 in the next one.